Hello all, welcome to the lecture Recent Trends in Automobile Engineering. I am Rajesh Kumar, Assistant Professor, the Department of Automobile Engineering, SNS College of Technology. Today we are going to see scavenging in IC engines. So before into the topic, we must know the meaning of scavenging. What do you mean by scavenging? Scavenging is the process of eliminating the burnt fuel from the combustion chamber. In two-stroke engine, scavenging is the main parameter which is used to eliminate the burn fuel. Unlike four-stroke engines, two-stroke engine have the difficulty of eliminating the burn fuel. So this elimination process is called scavenging. Scavenging is used in two-stroke engines, which is for the purpose of removal of burnt gases and introduction of the fresh charge, as well as mixing of the gases, and then the cycle repeats again and again. So this slide shows the anatomy of a two-stroke engine. So a two-stroke engine generally consists of ports, whereas a four-stroke engine generally consists of valves. In two-stroke engine, there are three ports. One is inlet port. It is used for the entry of the air-fuel mixture. You can see here, it is indicated here. The next is the transfer port. Transfer port lies in between the inlet and the exhaust port, which is used to transfer the fresh charge of fuel by the action of the crankcase compression. Next is the exhaust port, that is the third port. This port is used for the outlet of the burnt gas. So you can see the first diagram, which is indicating the various parts of the two-stroke engine. The main component of a two-stroke engine here is the spark plug. This spark plug is a component which is used to ignite the air-fuel mixture. The second component is the piston. The piston is a reciprocating component where you can see in the animations cited next to the indication. You can see here. So this piston is connected with the connecting rod which is connected to the crankshaft. So the piston moves from bottom dead center, that is the bottommost position, and the top dead center. In between this BDC, that is bottom dead center and top dead center, the piston moves. This movement is called stroke. Next is the reed valve. This reed valve is used to open the intake port so that the fresh air fuel mixture gets inside. Other than this, the entire movement of the piston lies inside the chamber, that is called combustion chamber, that lies above the piston. So you can see how scavenging is working. The third animation shows you that the elimination of the burn fuel, by the introduction of the fresh charge. So once the power stroke is attained, what happens here is the burn fuel to be eliminated or it to be sent through the exhaust port. So here through the transfer port, the fresh charge of fuel enters inside so that already burn fuel gets outside. So this process is called scavenging. Generally, scavenging is used to complete the exhaust gas removal and efficient charging and minimizing the short circuiting. It has very low flow resistance. Generally, there are different parameters that are used in the scavenging, out of which major things are the scavenging ratio, the delivery ratio, the trapping efficiency, and scavenging efficiency. There are three different types of scavenging. They are loop scavenging, cross scavenging, and Uniflow scavenging. Let us see one by one. So this diagram indicates the construction of the cross flow, loop flow, and Uniflow scavenging. You can see the cross flow scavenging arrangement. Here the intake and the exhaust port both are arranged in the opposite direction. The blue color is the intake port and the red color indicates the exhaust port. The second is the loop scavenging. You can see here the intake and the exhaust lies in the same side of the combustion chamber. So the intake port lies below the exhaust port. The last type is the uniflow scavenging. Here you can see here the fuel enters at the bottom and exits the burnt gas at the top. So these are the three different types. When we compare these three different types of scavenging process, we can see here the first difference is the port arrangement. As I told you already, the cross flow consists of opposite the arrangement of intake and the exhaust port. Whereas the loop scavenging, the intake and the exhaust lies in the same side. The uniflow you can see here enters at the bottom, exits at the top. The flow direction. Here the flow direction in cross flow is the across the cylinder, whereas the loop it is the looping above the piston. And the uniflow scavenging you can see the flow direction is straight. And the efficiency out of three different types of scavenging process, the uniflow has the highest efficiency. And the application part, if we come to the application part, it is used in the cross flow scavenging is used in the older engines. The loop flow scavenging is used in the vintage and the some selective modern two-stroke engines. And the uniflow scavenging is mostly used in the marine application. So that's it about the scavenging process, and we will meet in the next video. Thank you.